Okay, so this is lesson 6.4, no, 6.3, sorry about that. I'm going to start on page 309. I'm basically going to teach you the logistics of simplifying, and then I really do think I'm going to save some of this information Friday when we're in person, because there are some little tidbits here that are going to be a little bit hard to explain. We'll see how the video goes and I'll try it. But one thing that I am going to teach is kind of important, and you've spent most of your lives square rooting. And most things do get square rooted, but we have to talk about nth root. And when we say nth root, or when we say the word square root, the index is 2. It's understood, okay? So whenever there's not an index, there is an index, and it's called, it's just a square root. But if the index is anything else, like if you look at that one, they have to show it. That is the cube root of a number, okay? Cube root of a number. If there's a 4 there, it's fourth root. And I'll show you how to do this, but again, the only time you don't see it is when it's square root. But you have an index. Knowing the index is the most important part of simplifying a radical. Of course, these are radicals. This is called the radicand. It's not that big of a deal, but the index is a big deal. When we nth root, this table is kind of important, and I'll probably have to re-explain it, okay? But basically, and we've talked about a lot of this stuff, let's just deal with if a root is even. If I square root, you already know that there are 2 answers, a positive and negative answer, okay? And that is basically this scenario right here. And now we're saying n is even, so that's just not true for square root, it's true for fourth root, sixth root, and so on. So if it's even, there are 2 answers. You already know that. Something else you already know, that if the value is negative, okay, like if I have a negative 36, the answer is plus or minus 6i. Now the book right here says there are 0 real roots, okay, which is true, and that's the same thing as saying there's 2 imaginary roots. And then the last one is, like, what is the square root of 0? And we've kind of already talked about that when we talk about discriminant. The square root of 0 is just 0, so you get 1 real root. Now, something a little different is if the n is odd, and we'll just do cube root, okay? When you cube root, there is only 1 real answer. Like the cube root of 8 is this scenario right here. Is just 2. So why do you not get 2 answers? It's a good question. But if we go back to square root, the square root of 36, we can get that by doing 6 times 6. We can get it by doing negative 6 times negative 6. That's how we get 2 answers. The cube root of 8 is 2 times 2 times 2, which is 8. If I try the negative version of that, hold on just a second.
Attention seniors.
So if I do negative 2 times negative 2 times negative 2, I get negative 8, which is not 8. So that means the cube root of 8 only has 1 root. You can do the cube root of negative 8. Okay, so you don't actually get an imaginary answer. That's a real answer, and that's this scenario right here. So the cube root of negative 8 is just negative 2. So whenever you cube root a negative, you also get 1 real answer. And then technically when you cube root anything, you also get 1 real answer, because the cube root of 0 is just 0. So long story short, if n is odd, you have 1 real solution, no matter what. If n is even and your number's positive, you have 2 real solutions. Negative, 2 imaginary, or 0 real, and 0 is 1 real. So actually not a whole lot new there. Now this is pretty easy when everything is perfect. You know, if it's a perfect cube or a perfect square, it's all pretty easy. If you don't know it, I will say, like, you can type the numbers in your calculator. You can't type variables, but when you start doing this, you can type numbers in your calculator. And, square roots where it's always been, here's 25. If you want a cube root, you can hit the math button and go down to number 4. And if you want to do a 4th root or 5th root, you can do number 5 down here at math, but you have to type in the root first. Like if I want a 4th root, I'm going to hit 4 first, then go down to that, and I can 4th root something. And again, cube root is math right here. We can cube root. But numbers you can still put in if you don't know. And just, like whatever sign they throw out front, put in your answer. So what is the cube root of 25 plus or minus 25 is plus or minus 5. Now the variables, while you can't put them in your calculator, they're actually really easy too. Basically, to get them, you just have to divide the exponent by the index. And I'm having a hard time going to put a 2 in here. But how do I get the answer? Well, basically, I do the power of the exponent divide by the index, and so 4 divided by 2 is 2, and so my answer here is plus or minus 5x squared. If you look at problem B, what sign was out front? They just kept it, and since this was an entire expression, they divided that power by the index, and so 12 divided by 2 is 6, so this is y squared plus 7 to the 6th. We'll keep working through this. Problem C is the cube root of 343. So I already have this pulled up, but I'll show you again. Math, down to number 4, or just click 4. And again, you can do 343 in your calculator. I doubt any of you know that, so that's 7. So 7. They didn't throw a sign out front, so I won't. And then how do I do the cube root of a to the 18? I do 18 divided by 3. That's going to be 6, I believe. Okay. B6, the cube root of B6, you can just do 6 divided by 3, and that is b squared. So my answer is 7ab squared. Now, problem D, we are square rooting. I don't actually know how they're going to say it's non-real, but you know how to do that. So we can do imaginary answers. Now, some calculators, depending on their mode, might do the square root of negative 289. We'll see what mine does. But it's going to say non-real because it is non-real, but you can do the square root of positive 289, which is 17, and you should know it as 17i. Okay? And then same thing. Power by the index. So the index is 2 when it's not written. We've already talked about that. And what is 8 divided by 2? But C, 4, and 4 divided by 2, D2. So that should be pretty easy. When we run down to example 2, they talk about using absolute values and when you're supposed to use absolute values, and it is kind of a weird rule. But basically, when you're doing an even root of an even power and the result is odd, and all I know to do is to say that over and over and over, an even root of an even power and the result is odd. And that is in this example here, and they do have the answer, but I'll show you how to get the answer. They do the 4th root of 81, which I don't expect anybody to have memorized. So how do you do 4th root? Math, or 4 first, because we're doing 4th root. Go down to number 5, or just simply press 5. We do 81, and that value is 3. So that's how they get the 3. And then how do they get just x? Well, they did the exponent by the index. So that's x1. You don't have to write a power of 1. And then why did they do absolute values? Because the root was even, the power is even, and the answer is odd. And when that happens, you use absolute values. The next examples are about switching forms, and once you get the pattern done, I don't know, there's not enough homework problems, so I guess I'll do those in the examples. But, hold on just a second. I guess I'll show you example 3, but I still might do some of these in the homework. They should still be pretty easy, and basically what you're supposed to know out of this is there's an equivalent form writing an exponent to radical. Okay, now if it's a radical, the exponent's going to be a fraction, and that's okay, but what is the rule? Well, I like to, and this is basic memorization, and I basically like to memorize that the index, when written as a fraction, is on the bottom. Okay? When we do this conversion, the index is on the bottom. So if I was doing example B, I would say x, and again, if you heard me say that, the index has to be on the bottom of a fraction. So that's 2 over 5, and that's to the power, to the 2/5 power. So you just got to write it as a fraction or vice versa, and you just got to know where the numbers go again. And so I just memorize it one way by saying index on the bottom. I think I should probably do a couple of those problems in the homework because that's not enough. And there's more to this section. I think I'll save example 5 and example 6 for Monday, not to overwhelm you. Try to make it easy for you. And again, we can do some of this. Like the answer to number 1 is plus or minus 11, square root of 121. You can type in your calculator. X squared, how did I get it? Power divided by index, so 4 divided by 2. Y 8, and 16 divided by 2 is 8. So that's easy. Going back to the switching forms, again, I don't want to do all of these. But what did I say? If you're going to write it, so this is in exponential form, and they want us to write it in radical form. So we're going to put a radical, and which one did I say was the index? And so the index is 5 because I said it's on the bottom. So that's the 5th root of 8 to the 1 power. Okay? And you don't have to write 1 power, but just to give you the visual. 16 is easy. You might think it's hard. What's the index? It's not there, so it's 2. What is 17's power? Well, it's 1. So how do I, since that one's in radical form, how do I write it in exponential? And that is 17 to the 1/2 power. Don't forget you can check your answers. I might do one more of these. Some of these can be kind of tricky. Like if I was going to do 17, you might write it 2 different ways. One of those ways is to say all of 5xy squared in parentheses. And again, we're going to do that to the 1/3 power. That's probably the easiest way to write it. If you check your answers in the back of the book, some of these may be written different. And when we check your work on Monday, I might show you how to see if they're equivalent or not. The other way to do this problem would be to do every term to the 1/3 power. Like you could distribute your 1/3 here, or you could write it like this. You could say 5 to the 1/3, x to the 1/3. You wouldn't say y to the 1/3 because y has an exponent of 2. You would say y to the 2/3. And so that's going from radical to exponential form, vice versa. Like I said, I think we'll stop there because that should be enough. I will say I think I might assign some of these problems too, like 21 through 26, and all you have to do on those, if you have your calculator, is type them in. So like I'm going to do number 21, I can type in 27 simply to the 1/3 power. I will show you how it's equivalent to the cube root of 27, right? If we were to write that as a radical, I was about to do square root, so I'm going to hit math, and they're equivalent because they're the same. So 27 to the 1/3 power is 3, and so is the cube root of 27. Again, you don't have to do it twice, just showing that they're equivalent. I'll stop there, let you do your homework. That way you can have a good weekend.